Okay, we are recording, I believe. Let me double check. Yeah. All right, let's start with a prayer. Father God, we thank you for another opportunity to come to your presence and also to study about your great wisdom in creating this world, which is manifested in the science of mathematics. We commit this class again into your hand. Guide and lead us. And I do pray for all these dear students that you bless them. Tomorrow, Thanksgiving Day, may they all have a wonderful time with their families and friends. And especially protect us in this rainy weather or snowy weather, depending where each student is. We commit tonight and tomorrow, the rest of this week, into your hand. In Jesus' mighty name we pray. Amen.
Jesus' name, amen.
Okay. Tonight, we are going to study about algebra, which I really like algebra. It's easy to follow, very logical, like everything else in mathematics. But let me go to the larger screen.
I hated algebra.
Oh, I'm sorry. I'm sorry to hear that.
It scared me.
No. If you understand it, then it's easy. Basically, algebra is a generalized form of arithmetic. What you have in an algebra, you have a bunch of letters or alphabets called variable, and then you have some variable means their content, their value can change. And then you have also what some that are constant, and they are called constant. They're symbols that are constant. So we have variable, constant, and we put them together in addition, multiplication, division within a parenthesis, and then that is called algebraic expression or expression. And if two algebraic expression is there, if there is an equal sign between them, then you have an equation, and we can find solution for an equation when we solve the equation. By solving is you find the value of that variable or the range of value for that variable. To evaluate an expression means to find the value of the expression for a given value of the variable. Now, what do I mean? Let's look at example. Let's look at our textbook. Go to page 309. Hello. Hi. How? Good. Yeah, I'm online right now. That's okay. Is there something I can help you? Oh yeah. My in-class student are not coming. I told them to stay home and join me online. It's better because of the weather. Yeah. No, don't worry. Have a good Thanksgiving Day. Dr. Mute from the next door. Okay. Okay, look at example 1 of page 309. And I can go to our own iPad. Okay, it says, here, look, it says we have 7 plus 5 times x minus 4 to power of 3. It says...
Can I ask a question real quick?
Sure.
Because right now my brain is just flashback, 40 years to high school.
Okay.
So it says evaluate. What does evaluate mean? Does it mean solve?
Solve this expression
Okay.
for that value of x. The value of x is 6. Okay. For x given as 6, it tells you to solve this equation, that expression actually. So what we do, we put, instead of x, we put 6. So I have 6 minus 4 to the power of 3. And that parenthesis, because 6 minus 4 is 2, 2 to the power of 3. I have 5 here and 7. So I get 7 plus, what is 2 to the power of 3? 8. Or if you want, I can write it for you. 2 times 2 times 2. So it would be 2 times 2, 4, 4 times 2, 8. So I have 7 plus 5 times 8. And that is 7 plus 5 times 8 is 40. So I get 47, the final answer. That means to evaluate, this is an algebraic expression, what we have here.
You just lost me. How'd you get 47?
Okay, this was given to us. This is an expression, algebraic expression, right?
7 plus 5 is 12. 12 times 8. You know what you're looking at?
Yeah. You see, that's the expression. They say evaluate that for x being 6. So you put 6 for x. 6 minus 4 is 2.
Right. I got that part.
Okay. All right. Then, so we have 7 plus 5 times 2 to the power of 3.
Right. Got that part.
So you have 2 times 2 times 2.
Right.
So
got that part.
7 plus 5, 2 times 2 times 2 is 8.
Right.
So I have 7 plus 5 times 8 is 40. So I have 7 plus 40.
Oh, okay. I see what you did. You went 5 times 8 is 40 plus 7 is 47.
Yeah.
Okay. I was looking at it as 7 plus 5 is 12 times 8.
No.
Okay.
Remember the order of operation. Remember the order of operation is we have the first, you see, I did that, that expression that I gave you guys, forgive my dear old Aunt Sally. First we took care of the inside the parentheses.
Yeah, okay.
Then we took care of the exponent.
Yeah.
Then we took care of the multiplication.
Okay.
Then we add. Yeah.
Got it. That's where you lost me.
Okay, no problem. Or let's look at example number 2. Let me clean the sheet here. My computer is slow. Okay. All right. Let's look at example number 2 of this on the same page. You're on page 309 of our textbook. Example number 2. We have x2 plus 5x minus 3. And they say now solve this when x is equal to minus 6. Evaluate or solve means the same thing.
Okay.
So instead of x, I put minus 6. I have minus 6 to the power of 2 plus 5 times minus 6 and minus 3. Okay, want to know what would be the value of that. Minus 6 to the power of 2 is minus 6 times minus 6. Minus times minus becomes
positive.
Okay. 6 times 6 becomes
36.
Yeah. Okay. Now I have negative 6 plus 5. Plus times negative becomes negative.
A negative.
Yeah.
Whenever a negative and a positive is a negative.
Yeah. Whenever the signs are not the same in multiplication or division, it becomes negative. 5 times 6 is 30. Okay. Minus 3. So I have 36 minus 30 and minus 3 become minus 33. Follow me? And
Yes.
36 minus 3 becomes 3 plus 3. Okay?
Yep.
All right.
So good.
Okay. Now we can even have, let's do example number 3 also, when we have two variable. Again, we are on page 309 of our textbook. Example number 3, it's minus 2x2 minus 5xy minus y to power of cube 3. Then they say evaluate it when x is 4 and y is minus 2. So now we have two variables. Doesn't matter. We just plug in for wherever there is an x, we put 4. Wherever there is y, we put minus 2. So we get minus x. I have an x here. 4 to power of 2. And I have 5. X is 4. Y is minus 2. Minus 2 to power of 3, okay? I just put, instead of x, I put 4, instead of y, I put minus 2, all right? So then minus 2 times 4 to power of 2 is 16. Okay, here we have minus 2 times 4 becomes minus 8. So I have 5 times minus 8 minus, then I have minus 2 times 3 times. Okay, oh. Well, maybe I better put it this way. Are you following me so far?
Yes.
Okay, so minus 2 times 16 becomes minus 32. Minus 5 times minus 8, minus times minus becomes plus. 5 times 8 is 40. Okay? Minus, then minus 2 times minus 2 becomes plus 4. Plus 4 times minus 2 become minus 8. All right? So far, are you following me?
No.
Okay.
So
Okay. Where did you lose me? Here?
Where you went minus 2 plus times minus 2?
Okay. You see, here, if you look at here, this part, I have minus 2 times minus 2.
Right.
Minus 2 minus times minus is plus.
Right.
2 times 2 is 4.
Correct.
Okay. Then I have plus 4 times
okay.
minus 2.
I see it now. Yeah.
Becomes minus 8.
Becomes a minus. Yep.
Okay. So I have minus 32 plus 40. Now I have minus times minus 8. Minus times minus becomes plus. So I get plus 8.
Right.
So you add this becomes minus 32 plus 48, which is equal to plus 16. Which I hope it's correct.
Take it.
No? I did it wrong. What did I do wrong?
You went minus 5 instead of plus 5.
Where?
At the very beginning.
Oh. Oh, yeah. yeah, I went minus. So actually, the problem in the textbook has plus. So I went, if you go plus, then this pen is not. Then this becomes plus, then this becomes plus, then this becomes negative plus times minus 40. So this becomes minus 40. So you end up with minus 72 plus 8, which is equal to, yeah, minus 64. So, forgive me, I haven't changed the sign for this term. Okay? Are you okay now?
Yes.
Now, in an algebraic expression, things like this are called term. You know, like this algebraic expression has 3 terms in it. All right?
Okay.
Let's go back to our PowerPoint. All right. Okay, we did that. Now, some of the vocabulary, as I mentioned, you know, like if you have an expression 7x minus 9y minus 3, each of these 7x minus 9y and minus 3, each of them is called a term. So this equation or this expression has 3 terms. X and y are variables. 7 minus 9 minus 7 and minus 9 are coefficient, meaning they are multiplied by the variable, and minus 3 is a constant. Okay? So x and y are variable, 7 is a coefficient, and minus 3 is a constant. The value doesn't change. Coefficient is the number that is multiplied by a variable. All right?
Okay.
Now, we can add like terms, like when in a previous slide, we had 3x plus 7x. These are the like terms because their variables are the same. There is no y here if there is no x squared. If this was 3x squared, they were not like terms. But when you have the same variable and their exponents are the same, you can add them. 3x and 7x become 10x. Or you can, in other words, you can use the distributive property of real number to simplify algebraic expression. Let's look at page 314 and 315 of our textbook. And I do maybe says I do example 62, or let's do a couple of them. Example 41 and 62. Let me go to our own pad again. Again, clean up here. So I'm on page 315, exercise set 6.1. I'm going to do number 41. Very simple one. 7x plus 10x. It says simplify the algebraic expression. Look, this is one term, this is another term. And these are like terms. Why? Because they have the same variable and the exponent of the variables are the same. Right. So I can just add them. That would be equal 7 plus 10 is 17x.
Right.
Let's do, for example, number 62. Okay, it says 7x doesn't reach it. 7x minus 4, then I have a brackets, 6 minus parentheses 8 minus 5x, and then close the brackets. We want to solve this or simplify this. We are simplifying. So I start from here. inside the parentheses.
Right.
So this becomes 6 minus, well, actually, I will multiply this negative number into the parentheses. So there's nothing I can do inside just by itself. So I want to remove this parentheses. So minus times plus 8 becomes minus 8. Yes?
Right.
Then I have minus times minus 5x becomes plus 5x. Okay?
Do that again.
Okay. Minus times this minus became 5x, plus 5x.
Right.
Okay. So I have here minus 4 brackets. 6 minus 8 becomes minus 2. So let me do that. Six minus 8 become minus 2.
Right.
Plus 5x. And close that. Then I take, you see, here comes distributive property. I take this minus 4, multiply it by the inside. I get minus 4 times minus 2 is what? Plus 4. Plus 8, I'm sorry. 4 times 2, 8. Minus times minus is plus.
Okay.
Okay. Then minus 4 times plus 5x. Minus times positive becomes negative. 4 times 5, 20. So I get 20x. So this whole thing, including the sign, became this. Are you following?
I do.
Okay. So I get 7x plus 8 minus 20x, which is equal. Again, this term here and the term here, they're like terms. They have the same variable, same exponent. This is minus 20x, this is plus 7x. They become minus 13x. And this 8 remains the same. So that's the farthest you can get. This would be the answer. Okay?
Okay.
Everything clear here?
It is.
Okay, good.
I follow that.
All right. Then let's continue. Okay. All right.
Can I do one just to make sure I'm clear?
Sure.
Can we do 55?
Okay, so let me go back. Okay, let's go back and let's clean this. Okay, let's do number 55. Sure. So we are on page 315. We are on page 315, and we are doing number 55. Number 55 says 5 times 3y minus 2 minus parentheses 7y where am I? Plus 2. Okay?
Okay.
So we want to simplify this. Again, I use the distributive property. I multiply 5 inside the parentheses. 5 times 3y becomes 15y. Okay? 5 times minus 2 becomes minus 10. All right?
Okay.
Then, when I have here negative and there is no number, there is actually a 1 here. Okay? You don't have to write it. So you get minus 1 times 7y you get minus 7y. And you have minus 1 times plus 2, you get minus 2. All right? So this is one of my terms, this is another term. They are like terms. The variables are the same. The exponents are the same. So I can add them, or actually in this case, subtract them. 15y minus 7y becomes 8y. And then I have minus 10 and minus 2. They get added up to minus 12. So that's the final answer.
Okay.
Okay?
Yep.
All right. So let's continue. Let me clean up here. Next one. And okay, so as you see, we added up like terms and we used the distributive property. We simplify algebraic expression. Now, let me go here. We want to also, we will have other kind of equation. The first type of equation we want to solve is a linear equation. Now, by linear, what I mean, or what math means, it's a straight line. And let me tell you a secret here. When you have the exponent is only 1, you can always know that this is going to be a straight line. If it's square or cubic, then you will have curvature shapes. This is a general formula for a linear equation. A times x plus b equal to 0. To solve this algebraic expression means find a value for x that make this equal to 0. And a and b will be given to you. A will not be 0, and for a and b are real numbers and a is not 0, then they tell you to solve this problem. Okay, now the variable can be y, can be c, it can be any other letter, but this is a basic form of a linear equation. Okay, now let's go to page 318 of our textbook. And you can see those addition property, multiplication property can apply. For example, you see that green shaded table in the middle of page 318.
Yes.
Let me go to the. For example, it says if you have an expression, you got to remember, if you have an expression a is equal, if a is equal to b, if I add c to both sides, the equality still holds. If I add c to both sides. Or if a is equal to b, I multiply both sides by a c, the equality still holds. I can divide both sides by c, and equality still holds. To remember this thing will help you in solving algebraic linear equation. For example, let's look at the bottom of that page on table 6.1. Says, for example, if you have x minus 3 equal to 8, okay? It tells you solve this algebraic expression. What it means is find the value of x that makes this statement true. In order to do that, you want to isolate the variable on one side and make sure its coefficient is 1. So, well, fortunately here, the coefficient is by itself 1. So in order to isolate, I need to get rid of this minus 3. So I add plus 3 to both sides. And based upon this rule, a plus b,
Keep going.
Okay, based on this rule that says a is equal to b, I can add a number to both sides and the equality holds. If I add plus 3 to both sides, this minus 3 and this plus 3 cancels, and you get x is equal 8 plus 3, or 11. Okay? Let's do, for example, this one, 6x equal to 30. Okay? Now, what it's asking you to do is find the value, and you can always, something else, when you find a number, put it back in that expression to check to make sure that your answer is correct. If I put 11 back into x minus 3, I get 11 minus 3 equal to 8. So my answer was correct. For this one, 6x equal to 30. Okay. You want to have the variable on one side. I already have that. But you also want to have the coefficient to become 1. I have 6 here. So what do I have to do? Divide both sides by 6. That will not change the value of the equation. 6 divided by 6 becomes 1. So x is equal to 30 over divided by 6 is 5. That's answer.
Okay.
Let's do this one. For example, you may have x over 5 equal to 9. Again, you want to have variable on one side, but the coefficient 1. The coefficient is not 1 here. The coefficient is actually 1 over 5. So I want to make that 1. So what should I do? I multiply both sides by 5. So this 5 cancels out with that. I get x is equal 9 times 5, which is equal to 45. All right?
Yeah.
So, and you always can check, because if you put this number back into the original formula, 45 divided by 5 is equal to 9. All right. So let's go back to our PowerPoint. Right. You know, in this slide, I'm just writing what I just showed you. So in order to simplify the expression, you want to collect the variables, all the variable terms on one side, constant numerical on the other side, isolate the variable, solve it for that variable, and then put it back in the original formula to make sure that your answer is correct. All right, let's go to page 328. Sorry. Let's do a couple of these. Okay, we are on page 328, exercise set 6.2. Let's do, for example, number 14. Okay, I'm doing number 14, which says 3x plus 8 is equal to 50. It says solve this problem, solve this equation for x. What it means is find the value of x that makes this expression true. So first, you want to have all your variable on one side, all the other numbers on the other side. I want to get rid of this plus 8 here, so I add minus 8 to both sides. All right, clean this also. This minus 8 plus 8 and minus 8 cancel out. So I get 3x equal 50 minus 8, which is equal to 42. Okay? Now I want to make the coefficient of x to become 1. So I have to divide both sides by 3. 3 is divided by 3, so you get x is equal to 42 divided by 3, which if you do the division is actually 14. All right? So the value of x is 14. Do you see that?
Yeah.
Okay. Now, in order to check, put 14 back in the equation. You get 3 times 14 plus 8 equal to 50. 3 times 14 would be 42. 42 plus 8 is 50. So, yes, 50 is equal to 50. So this value is true. All right?
Mm-hmm.
Let's do another one. Let's do number 31. Let's do number 31. I have 8y minus 3 equal to 11y plus 9. Okay, so first I want all my variable on one side, all the numbers on the other side. So I want to bring this 11y to this side. So I want to get rid of it from here. So minus 11y, I add minus 11y to here. I have to add minus 11y to this side too. These two cancel out. So I get 8 minus 11y minus 8y, I'm sorry, 8y minus 11y minus 3 equal to 9. All right? Now I want to get rid of this minus 3 from this side. So I add plus 3 here, and I add plus 3 here. This cancels out with that. I get 8y minus 11y equal to 12. Okay?
Okay.
Now 8y minus 11y is equal to minus 3y. So minus 3y is equal to 12. Are you following me?
Yes.
All right. Now, I need to make the coefficient here 1, positive 1. So I need to divide both sides by, if I want to make that positive 1, I need to divide it by a negative 3. All right?
Right.
So minus 3 divided by minus 3 is plus 1. So I get plus y. 12 divided by minus 3 is minus 4. Now to check it, put this minus 4 back into the equation. If I do that, I get 8 times minus 4 minus 3 would be equal 8 times 4, 32 with a minus sign. I get minus 32 minus 3, so I get minus 35. On the other side, I have 11y plus 9. 11 times minus 4 plus 9. 11 times minus 4, if I come here, become minus 44 plus 9 becomes minus 35. So I got 35 on both sides. So the answer is correct. For y equal to minus 4, this equation is true. You see that?
You lost me in there somewhere.
Okay, tell me where did I lose you? Okay.
That 8 times minus 4.
8 times minus 4. 8 times 4 is 32. Okay, but I have a minus sign here. This minus sign times plus sign make it minus. So I get minus 32 minus 3. Let me clean it up. Maybe that makes it better. Okay. You see, we have. If I got the value. Was it clear how I got y equal to minus 4?
Go back over that for me.
Okay, you see, what I did was I brought all the variable to one side. I want to get rid of minus 3 here. And I want to get rid of, first I want to get rid of this 11y from this side. So I subtract minus 11y from here, then I have to do it over there too, on the other side.
Right.
So I get 8y minus 11y minus 3, then these two cancel is equal to 9. Now I want to get rid of this minus 3 from here too. I want to have only variable on one side and only numbers on the other side. Okay, so I add plus 3 to both. These two are canceled. Plus 3 plus 9 becomes 12. So I get 8y minus 11y. Okay, so far so good?
Yep.
Okay, 8 minus 11 is minus 3. So I get minus 3y equal to 12. All right?
Okay.
Then I divide both sides because I want to make the coefficient here plus 1. I divide both sides by minus 3. I get y is equal to minus 4.
Okay.
Then I put minus 4 back into the equation just to check my answer, to make sure it's correct. So I get 8 times minus 4.
Ah, there it is.
8 times minus 4 is minus 32.
Okay. Yep.
Minus 3 becomes minus 35. And if I put minus 4 for y here, 11 times minus 4 is minus 44. Plus 9 is equal to minus 35.
Yep,
So,
got it.
okay.
Yep.
All right, good. Let's do just one more. Let's do number 64 on page 329. We have minus 3 over 8 equal to 6 over x. We want to solve for the value of x that makes this equation true. So I want to have, x is on one side, but I wanted to bring it up. I don't want it to be on the denominator. So I have to multiply, if I want to get rid of this 6 here, so I have to multiply this side by, actually, let me see if I multiply it by, yeah, I multiply by x, then I have to multiply by x here, okay? If I do that, this x with this x cancels out. So I get 6 equal to x times minus 3 over 8. Okay?
Okay.
So far, so good?
So far, so good.
Okay. Now, I want to get rid of this part here. I want to make that equal to 1. So I have to multiply by the inversion of it. 8 over 3 with a minus sign, but then I have to do the same over here. 8 over 3 with a minus sign. So this minus sign cancels out with that. This 8 cancels out with that. So I get x is equal to 6 times 8 divided by 3. Are you following me?
Yes.
Okay. Now, 6 times 8 is 48 divided by 3 makes it to become minus, because this is plus divided by minus minus. 48 divided by 3 is 16. Okay?
Okay.
So if I plug it back, just to make sure that my answer is correct, the original formula was minus 3 over 8 equal 6 over x. Now, instead of x, I put minus 16. Okay? Well, let's see if this is true or not. I can divide the top by 2, it becomes 3. I divide this side, I have to divide the denominator by 2, it becomes 8. And since it's negative, makes the whole thing negative, like here. So I get minus 3 over 8 equal to minus 3 over 8. So my answer is correct.
Okay.
All right?
Got it.
Good. Let's go back to let me first clean up here. Go back to our PowerPoint. Okay. Now, a thing to remember that helps you to, like what we did right now, to speed up your problem solving is a cross product principle for proportion. If you have A over B equal to C over D, then if you multiply this A by this one, D here, and this C by B, they are equal to. Okay, this is called the cross product principle. A times D is equal to B times C. All right, for example, let's go to page 325 of our textbook. And let me page 325, example number 7. We are on page 325, example 7. We have, for example, 63x is equal to 7/5. This principle makes my work much easier. The principle tells me that this is the same as if I multiply 63 by 5 is the same as 7 times x. Okay? I multiply this side and then this side. All right? Now 63 times 5 is 315 is equal to 7x. Are you following me?
Yes.
Now if I divide both sides by 7 to make the coefficient of x equal to 1, so I get 315 divided by 7 would be 45. You know how to do that. Is equal to x. So this is the answer for x. All right?
Got it.
Okay, we can do another one to just make sure. Number B, if you have 20 over x minus 10 equal 30 over x. Again, the cross-section principle. So I multiply this side by this side and this side by this side. 20 times x is equal 30 times parentheses x minus 10. Okay?
Okay.
So this side becomes 30 times x, 30x, 30 times minus 10 minus 300 equal to 20x. Now, I want to have x's on one side, numbers on the other side. I can add minus 20x to the both sides. These two cancels. This becomes 30x minus 20x becomes plus 10x. This side becomes 0 equal minus 300. Then I add 300 to both sides. And let me write it here. So I get 300 plus 0 is 300 equal 10x, and these two cancel out. Okay?
Okay.
So I get 300 is equal to 10x. I divide both sides by 300. Oh, actually, no, sorry, by 10. I divide both sides by 10. I want to make coefficient of x equal to 1. So these two cancel. 300 divided by 10 becomes 30. So x is equal to 30. All right?
Yep.
Good, good. So let me see. There was another. Let's also go to, while we are on the pad, to page 329. And again, maybe do one example of that. Oops. I guess, like number 64 on page 329. I have minus 3 over 8 is equal to 6 equal to x. Again, I multiply this side by this side and that side by that side. I get minus 3x equal to 48. I divide both sides by minus 3. So I get x is equal to minus 60. All right?
Yep.
Good. Shall we continue?
Mm-hmm.
Good. Okay. 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 If we go to page 332, it's on table 6.2. It's good to familiarize yourself with this expression to actually, translation between English and algebraic expression. For example, it says the sum of a number and a 7 means a number which is x plus 7. We don't know what that number is, so we call it x. The sum means addition. Okay? Or look at multiplication. It says, for example, 70% of a number used with decimal. Well, 75%, I'm sorry. 75% is the 0.75 of a number, meaning it multiplied by that number. Remember, when we wanted to find a percentage of a number, we will multiply that percentage by that number. Are you following me?
Yes.
Okay. If you look at the bottom of the table, the third line from the last line, it says 25% of the sum of it, 3 times a number and 14. So you have a number, we don't know what that number is, but we want it 3 times, so you have 3x, the sum of 3 times of a number and 14, so you get 3x plus 14, but you want to have the 25% of that. So you put that in a parenthesis and multiply by 0.25. These are examples given here to show you when you have a word problem, how to translate that into an algebraic expression. Are you following?
Yes.
Okay, good. Okay. Here, basically, in order to solve a word problem, read the problem very carefully at least twice. It's just like the principle that we use for interpretation and the study of the scripture. First, 3 main questions. Remember, what does it say? What does it mean? And what is its application for me? First, you got to know what the problem actually is saying, understand the problem. If it's possible, draw a sketch, visualize the problem. Then try to find out what are you looking for? What are you supposed to find? Determine which quantity you're being asked to find. Choose a letter to represent the unknown quantity. Then write down exactly what this letter represents. Write down the word problem as an equation and solve it for that unknown quantity. And answer the question or question asked and check your solution. For example, I believe, let's do some of this here. On page 333, let me just make sure that 333, let me forget these things. Don't want to keep coming back. 333, 336, 337, and 338. Okay. Let's go to our pad. Okay. But look at page 333. Example 1. It's a very good word problem. It says the graph in figure 6.4 shows the average yearly earning in the United States by the highest educational attainment. The average yearly salary of a man with an associate degree exceeds that of a man with some college degree by $3,000. The average yearly salary of a man with a bachelor degree or more exceeds that of a man with some college by $41,000. Combine the 3 men with each of these educational attainment earn $188,000 a year. Find the average yearly salary of a man with each of these level of education. Okay, so we first read this problem. The thing that we are trying to find the average annual income, annual salary of a man with these 3 levels of education: some college degree, associate degree, and a bachelor degree. So here, in step 1, our textbook give X, let X represent one of the unknown quantities. And usually, in order to work, you see, you go to the least, if you notice in the problem, all the numbers are given in comparison to the person that who has some college degree. So we call X the average yearly salary of a man with some college degree, okay? Then the problem tells us the person with a bachelor, with a, associate degree gets $3,000 more, whatever that this person income is. The one with a associate degree gets $3,000 more. So I just write 3,000 like 3, okay? Are you following me?
Yeah.
Then it says the person with a bachelor degree gets $40,000 more than a person with some college degree. So whatever the person earns with some college degree, if you add $41,000 to his income, you get a person with a bachelor degree, okay? This is a person with some college degree. This is a person with an associate degree, gets $3,000 more than the first one. And this is a person with a bachelor degree or higher, get $41,000 than the first one, okay?
Right.
Now it says the average annual income of a person from all these three levels is, where was it? $188,000 a year, okay? So what does it say? It means if I add the one with the some college degree plus the one with an associate degree, X plus 3, the one with bachelor degree or higher, I should get 188. Are you following me? See what I did? See, the one with some, the problem tells us, let's call
yeah, I'm following it now. Yeah.
Okay.
Okay.
So we add, so we get X, then we can add these like terms, X plus X plus X. I get 3X here. I cross them, so I get 3X. 3X plus 3 plus 41 is 44, equal to 188. Now I want to have all the numbers on one side, so I add minus 44 to each side. I get 3X equal to 144. Okay? You divide both sides by 3. So you get X equal to 48. In other words, average income of a person with some college degree is $48,000. The one with an associate degree would be 51. It would be 48 plus $3,000 more. And the one with the bachelor degree or higher would be $89,000. Are you following me?
Yes.
Okay, good. Now let's go to page 336. Clean up here. Let's do example number 4, a price reduction on a digital camera. So we are on page 336, example 4. It says, your local computer store is having a terrific sale on digital camera. After 40% sale, price reduction, you purchase a digital camera for $276. What was the camera price before the reduction, or what was the original price? So we are trying to find the original price of the camera. Hello. Hey, I sent you an email. I told you if you want, you can wait and just join online. I didn't want you to drive.
I saw it when I got here. I was already halfway.
Okay.
Yeah, maybe the next 2 classes I was to do online.
Okay.
Yeah.
Well, I'm glad that you made it safely.
It was bad. It was terrible.
Okay. We are on page 336 of our textbook, example 4. We are doing some of these word problem, translating them into algebraic expression to solve them. The problem was saying that you go and buy a digital camera from a store for $276. This is after a 40% reduction. We want to find what was the price of the camera in the beginning, the original price. If we call the original price X, that's unknown. So something was subtracted from the original price. How much was it? Was 40% off the original price. I don't know the original price, so I put it X. The 40% is same as 0.40, okay? You know, you can always 40%, remember, is 40 divided by 100, or you can write it as a decimal, 0.4. All right? So it says, if you take the original price and subtract 40% off from it, then how much I paid was $276. You see, what I did right now is I translated that word problem in English into an algebraic expression. X minus 0.40x is equal to 76. If I solve this for X, then I get the original price of the camera. So I have X minus, so I have here, let me, I have X minus 0.4x is equal to 276. 1x minus 0.4 is 0.6x equal to 276. Okay? Are you guys following me? You did what do you know what, you see what I did?
There's 0.6.
Okay, because this is 1x, this is 0.4x. When you have like terms, you can, you know, this is a like term. Both the variables are the same, the exponent are the same. So you subtract 1 minus 0.4. So I get 0.6. So 0.6x is equal to 276. Okay? Now I divide both sides by 0.6. These two cancel. So you get x is equal, let me write it here, x is equal 276 divided by 0.6. If you do the division, you get the answer for $460. So the original price was $460. They took 40% off from it, and you pay $276. Okay? Are you guys all right?
Okay.
Are you all right, Brian?
Yep, we're good.
All right. Then let's go to the other example. Let's see, which page was it? 337. We did that. 338. So we're on page 338, example 6. So the total price of an article purchased on a monthly deferred payment plan is described by the following formula. So the formula is given to us. T is equal D plus Pn. T is the total price. D is a down payment. And P is a monthly payment, and M is a number of months. So we have a monthly payment and number of months times number of months. Okay, this is a formula given. Okay, this is just given to us. So in this front, it asks us to solve the problem formula for P. So we want to find what is P. If this is the condition that is set for this deferred payment arrangement, I want to know how much monthly payment I have to pay. So I have T is equal to D plus Pn. Basically, I want to solve this problem for P, okay? So again, get all the other numbers or variable, whatever letters on one side. I want to get rid of this D. So I subtract D from both sides. Okay, these two cancel. So I get T minus D is equal to Pn. Now, remember, we need to have, when we are solving for an unknown, this is called the coefficient. The coefficient should be +1. I want to get rid of this m. I wanted to make it 1. So I have to divide both sides by n. When I do that, these two cancel. So the answer is this. My monthly payment would be the total price of whatever I'm buying, the article, whatever down payment I put, divided by the number of months. That will determine my monthly payment, okay? All right, everything clear? Let's go back to our PowerPoint. Now, oops. We will have also linear inequality in one variable. In solving an inequality, it is a process of finding what we are looking for. We are trying to find, we had equation, which is basically equality. Now we have inequality. So what you're looking for, you're trying to find set of numbers that make that inequality a true statement. These numbers are called solution, the solution that will satisfy that inequality. And the set of solution is called solution set for that inequality. We can graph linear inequality in one variable. Let's go to page 342 and 343. And the table on that page, and look at some of these examples. Let's go here. Okay. If you look at page 342, look at table 6.3. For example, it gives you this set, remember? You have all the x such that x is less than a. So what you're looking for, all the real number or less x than less than a. If this line represents a line of real number, and if a is here, remember this says less than a, not equal. So a has to be empty point here. It will cover all the point here, less than a. Okay? If it says a set of x such that x is less than and equal to a, then you have on your number line, you have to have a solid point for a. It includes a and all the way down, because it says less than or equal. Let me look at the bottom one here. It says x such that x is greater than a but less than b. You know, this is like you had it on your midterm, like when I use the word between a and b. It means you should not include a and b. It means if this is a real number, real number line, and if a is here, b is here, you have to keep these empty. And we are only looking at these points. Doesn't include a and b, because it says greater than a and less than b. We want a range of value for x from here, but not including a or b. This is in English, we use the word between. But if I put equal value here, then would be x is a real number greater than or equal to a and less than or equal to b. Then these points should be solved. Okay? Are you following me?
The solid and the not solid.
The solid means it includes a. It's greater than equal. Yeah, it's a line. Not the empty circle means it doesn't include a. For example, I say find all the odd numbers between 3 and 9. Now, I don't want 3 and I don't want 9. Would be 5 and 7. But if I say all the odd number from 3 to 9, I'm saying include 3 and 9 also. Okay? Let's go to example 1 on that same page. For example, example 1 says graph each set. The first one is we have a set of all x as a real number where x is less than 3. So if I have this, if this is my line of real numbers, and I have 0 here, I have 1, 2, 3, 4, so on, and -1, -2, -3, -4. And these are the points. Okay, when I say x less than, all the x less than 3, so here's a 3, should it be solid or empty?
Solid?
No, empty, because it says less than 3.
Okay.
Okay, so would be all the real number less than 3, all the way it goes here, but not including 3.
Got it.
Okay, if it says, look at number C, example number C, says all the set of x where x is greater than -1 but less than or equal to +3. So on my line number, a real line numbers graph. So I want it to be, if here is -1, should this point be solid or empty?
-1 should be
Yeah.
empty.
Empty, yes, because I say greater than, not equal. And if this 1, 2, 3, this is 3, how about this point? Should be solid or empty?
Solid.
Solid, yes. So you're looking for all the numbers between here, but not including -1. Okay? All right, let me see. All right, let's go back to our PowerPoint. Yeah. Now, we want to solve linear inequalities with one variable. When you want to do that, it's exactly like how we did with the linear equation, except if you multiply or divide the side by a negative number, you got to reverse the direction of inequality symbol. Okay, that's the only difference. We do the same thing as if it was an equality sign. If I multiply both sides by a negative number or divide by a negative number, I just have to change the inequality sign. Let me give you an example so it makes it clear. For example, here, let me write these things down so I don't forget. Okay, let's go to our pad and clean up here. The first example we have is on page 344, example number 2. So page 344, example number 2. We have, this is an equality we have. 4x minus 7 greater than or equal to 5. The reason we say inequality, it's because we don't have an equal sign. It says it is giving you a range of number for x that this statement can be true, okay? That's the reason we call it inequality. Now, how to solve this problem is treat it as if it was an equality sign. So I want to get rid of this -7 from here, all the numbers on one side, all my variable unknown on the other side. I add +7 for both sides. These two cancel. So I get 4x greater than or equal. 5 minus 7 is -2. Okay? Following me?
Why do they have 12?
Oh, wait a minute. Did I write something wrong? 4x minus 7 greater than equal to 5. I added, oh, no, I'm sorry. I made a mistake. This is +7, not -7. +7 plus 5 is +12. Yeah, sorry about that. Okay, are you okay?
Good.
All right, so I don't change the direction of inequality because I didn't multiply or divide anything by a negative number. Then I want to get rid of this coefficient. I want to make it to become equal to 1. So I divide both sides by +4. So 4 cancels with 4, so I get x is greater than or equal 12 divided by 4 is 3. That's the answer. For all x, for all numbers that are greater than or equal to 3, this inequality holds. You can try it. For example, let's pick a number greater than 3. Pick 4. Let's say x is equal to 4. So we get 4 times 4 is 16, minus 7. 16 minus 7 is 11, but that is greater than 5. So this is true. If I put 3 here, 3 times 4 is 12. 12 minus 7 is 5. 5 is greater than or equal, so is equal to 5. So this statement is still true. Okay? Following me?
Yeah.
Mhm.
So I treat this sign, don't let this sign scare you. I treat it as a equal sign. Only if I multiply or divide it by minus 3, I change the direction. Let's do another one. If we go to page 345, and let's do example A, for example. We have 1 over 3x less than 5. Treat this as an equal sign. We want to have this coefficient to become 1. What should I do? Multiply both sides by 3. This 3 cancels with that. So I get x is equal to 5 times 3, which is equal to 15. So this, for all x less than 15, this statement is true. Okay? Let's do number B, for example. Okay. Brian, are you doing okay?
I am. I'm following you.
Okay. Let's do number B. It says minus 3x less than 21. Now, here it's different because I want to change this part to plus 1. I have to divide both sides by minus 3. Okay? But when I do that, then I have to change the direction of this inequality. So minus 3 cancels with that. I get x. Because I'm dividing by a negative number, I have to change the direction of this inequality. It becomes greater than instead of less than. 21 divided by minus 3 is minus 7. So that's the answer. And if you want to graph it, would be if this is 7, 8, 9, and so forth, this should be empty, okay? Because it's greater, not equal. Let's go to page 366. If you don't mind, let me turn the heater on. It's getting cold in here.
Yeah.
One moment. Okay. Okay, let's go to page 366. But let me clean this. Okay. We do example 5, page 346. I'm sorry. This is 66. 346. Example 5. It says solve and graph the solution set for this inequality. We have 2 times x minus 3 plus 5x less than or equal to 8 times x minus 1. All right? So we use the distributive law. We multiply 2 inside the parentheses. So I get 2x, 2 times minus 3 minus 6. Are you guys okay? You see what I did? 2 times x, 2x, 2 times minus 3 minus 6, plus 5x less than or equal, I multiply this 8 inside this parenthesis, 8x minus 8. All right? So I collect the like, I want to have all my x on one side. I want to get rid of this minus x here. So I subtract minus x. Notice I'm not dividing or multiplying, I'm subtracting. So I don't need to change direction so far. So these two cancels. So I get 2x, oh, I'm sorry. I get 2x minus 6 plus 5x minus 8x less than or equal to minus 8. All right? Then I collect the like term. 2x plus 5x becomes 7x minus 8x become minus 1x. And I have minus 6 already here, okay? Less than or equal to minus 8. I want to get rid of this minus 1, so I add plus 6 to both sides. These two cancel. I get minus x is less than or equal, plus 6 minus 2 is minus 2, okay? Are you guys okay so far? But now, notice here, I don't want minus x, I want x. So I have to multiply both sides by negative 1. When I do that, I have to change the direction of the inequality. That becomes x is equal, greater or equal to 2. That's that.
So it's standard procedure for the sign to change
if I multiply or divide by a negative number, you got to change the direction of inequality. But notice I added minus x or subtracted minus x from both sides. I didn't change the direction of inequality because I'm subtracting only in division or multiplication with a negative number. All right. Are you okay, Brian?
Yes.
Okay. Now let's go to the other example. Example number 6 on page 347. Page 347, example number 6. Solve and graph the solutions, and the graph, you have it at the bottom of page 346. It will be solid, circle 2, and going all the way up. We have this inequality, minus 3 is greater than, minus 3 less than 2x plus 1 less than or equal to 3. Okay. Now, again, what I do is I want to have all my this is the given inequality. If I add minus 1 to both sides, I want to have my x by itself. So I want to get rid of this plus 1 here. So I add minus 1, and minus 1 to each side. This becomes minus 4, less than or equal. These two cancel. 2x less than or equal plus 2. Okay? Then I want to make this coefficient equal to plus 1. So I divide all the parts by 2. Minus 4 divided by 2 is minus 2. I'm not dividing by a negative number, so I don't change the direction of inequality. 2 divided by 2 is 1, so x less than or equal 2 divided by 2 is plus 1. So this is the answer. This inequality holds for all x between greater than minus 2, less than or equal to plus 1. On a drawing line, if you put that there, if you want to show it on a graph, if here is 0, and here is 1, 2, whatever, minus 1, minus 2, it would be, this point should be solid or empty? Minus 2.
Empty.
No, empty. Because notice, okay, this point plus 1 should be solid or empty?
Solid.
Solid, because it says less than or equal. So for all the numbers here, this inequality, that's a graph of this inequality. All right? You put any number, put minus 1. Minus 1 is greater than minus 2, is less than plus 1. All right?
What just off question, what branch of mathematics is this?
Algebra. This is algebra.
Now in application.
Oh, well, you will see the application will come, for example, in many ways, like we will see how, in fact, on page right 347, an application final course grade. To earn an A in a course, you must have a final average at least 90%. On the first 4 examination, you have graded 86, 88, 92, 84. If the final examination counts as 2 grades, what must you get on the final to earn an A? So you see, if you look at that bottom of page 347, that's an application. X represent unknown quality, your grade on the final exam, and it counts for 2, so you have 2x, and you have all these other scores that you got, and you divide them by 6 because there are 6 of them. Then when you solve it, so you need to get, and all this must be greater than or equal to 90 in order for you to get an A. So when you solve that, you need to get a 95 point on your final exam. Okay? All right. Good question. Let's go, let me see. Here. No, let's go back to our PowerPoint. Okay, we did that. 348. Oh, I can see that one. Oh, that's the same thing. Okay. Now, let's get here to the quadratic equation. We use what is called the FOIL method. And what I mean by FOIL, F stands for first, O for outer, I for inner, and L for last. You have 2 parentheses, and you want to multiply. In order to make sure that you are doing a correct way, you multiply A, the first element of each parenthesis, A times C, Then the outer, A times D. Okay, A times D are the outer. Then I, the inner, B times C. Then last, B times D, the last. This is the last element in the first parenthesis, and this is the last element in the second parenthesis. Brian, are you okay? Brian? We lost Brian. Hello? Oh, I don't know what happened. Anyway, so we use FOIL method for binomial equation or expression. A binomial is a simplified algebraic expression that contains two terms in which each exponent that appears on a variable is a whole number. Okay, these are, you got to look at example to understand what we're talking about. If you go to page 351, I don't know what happened to Brian. If you look at page 351, example 1. So we have, using FOIL method, we have parentheses x plus 3 times x plus 4. So first we use the first terms. The first terms are x and x. So x times x would be x squared. Then the outer terms, x and 4. These are the most outer elements. So I get 4x. Then the inner, 3 and x. So I get 3x. And the last, 3 and 4. 12. So you add these two, they're like terms, so you get x squared. 4x plus 3x are 7x plus 12. That's your final answer. Okay?
It doesn't go in, there's no expansion.
No, that's it. When they ask you to use the FOIL method for solving these two, that's all you want to do. I'll give you another example. On example 2, same page, page 351, example number 2, we have 3x plus 4 times 5x minus 3. Again, the first would be 3x times 5x would be 15x squared. And then outer would be 3x times minus 3 would be minus 9x. Inner 4 times 5x would be 20x. Hi, Brian. What happened? Are you there, Brian?
Yeah, lost my internet connection.
Oh, okay. We are using the FOIL method. We are on page 351, example 2. So you get 4 times the inner 4 times 5x, 20x, and the last 4 times minus 3, you get 12. So again, you add the like terms. This becomes 9x plus 20x becomes 11x minus 12. That's your answer. So, like, you know, if you see a question asks you to multiply these two parentheses, that's the way you do it. All right? Let's go to our PowerPoint again. Oh, 351. Okay. 352. On page 352, that green table is basically telling you that you just have this is doing it other way around. They tell you to factor. They give you a binomial expression. They say change it into the two parentheses. Let me just maybe. Okay. So if you have this expression, x2 plus bx plus c, now they change you to factor that into two parentheses. So we are doing the reverse of what we did previously. So you got two parentheses. You got, again, if I have x2, so that tells me I need to have x here and x here, and both of them positive because the sign here is positive. When I do the other number, you got to choose your number such that when you multiply them, you get c, but when you add the like terms, you get bx. That's the tricky part of trying to find that. So in other words, the sum, like it said, the sum of the outer and inner should become to bx, as you see here. The sum of the outer and inner should be dx. Let's try one example right there, example number 3, to make more sense. If I have this binomial equation and I want to factor it, so I need two parentheses, both of them x, both of them positive. But now, look at it. You want to have something. Now, I show you a trick. When you multiply them, you get 8. When you add them, you get 6. I can tell you it's 4 and 2. This is easy. It's x plus 4, x plus 2. You see, because 4 times 2 is plus 8. If you add them, 4 plus 2, you get 6. But in your textbook, he had tried all different numbers. So it tells you that you need to have, when you sum of the outer and inner should be, bx should be 6. This number here should be multiplication of that. So it does that. If you look at the step 3 on page 353, you see it tries all different numbers. It tries x plus 8 times x plus 1, x plus 4 times x plus 2, because it looks at all the factoring numbers for 8. It can be 8 and 1, 4 and 2, minus 8, minus 1, minus 4, minus 2. But the only one that gives you the sum of the outer and inner equal to 6 is the second option, x plus 4 times x plus 2, which I told you from here. You want two numbers that when they multiply becomes 8, when you add them becomes 6 plus 6. Okay? Are you guys okay? Are you following me?
slowly.
Okay, see, so they give you this expression, they say factor it, make it into two parentheses. So you write two parentheses, you want x and x, and then you have that all those options, you know the multiplication, the product of these two numbers should be 8. You can have plus 8 plus 1, plus 4 plus 2, minus 8 minus 1, minus 4 minus 2 on a step 3 on page 353. But among all these options, the only one that the sum of the outer and inner from that FOIL method will become 6x is plus 4 and plus 2. Okay? All right. So, are you okay, Dennis? Let's continue. All right. So basically, again, the same thing. This is FOIL method. First A and C, then first and the outer A and D, then the inner B and C, and the last B and D. Okay, we went over that. Okay, we come to trinomial is a simplified algebraic expression, contains 3 terms in which all the variables have a whole number of exponents. So like here, you have trinomial form. In order to factor, we can use again the FOIL method. Look, we have this expression x plus 3 with this negative sign here, times x plus 4. So you multiply FOIL method. First x times x squared, this negative makes it negative. Outer x times 4x, but the negative here makes it minus 4x. The inner 3 times x, 3x, the negative makes it minus 3x. 3 times 4, 12, minus 12. I add these two, become minus 7. And here I got trinomial algebraic expression. All right? Are you guys following me? Are you okay, Brian?
That's a lot to follow.
So, okay, just think of it one step by step. Okay. Strategies for factoring x plus 2bx. Let's go to page 352. Okay, we are on page 352. We did that. Okay. Example 3. Yeah, we did that already. Example 354. Okay, if we go to page 354, look at example number 5. Here you have the trinomial, tells us to factor it. So 3x to the power of 2 minus 2x plus 28. Again, maybe I better go to my so we have 3x power of 2 minus 20x plus 28. It tells us to factor it. So I want to have 2 parentheses, x and x. But remember, I have here 3. So one of them must be 3. I put 3 here. Okay? So I have 3x, then another parenthesis. Now, I don't know what's going to happen to the rest of them. So, but I know that you want to have the product of these two numbers here should add up to 28, okay? So if you look at that table on a step 3, page 354, it has given you different option for getting 28. -1 times -28, -28 times -1, -2 times -14, -14 times -2, and so forth. But among all these things, the only one that makes the middle term to become 20x is that fourth one at the, when you come fourth one on that table. So you get -14 and -2. Because if you multiply this, you get +28, and if you do the multiplication, you end up having -20x. Are you following, Brian?
Yes.
Okay, good. Or if you look at example 6, it tells you 8y2 minus 10y minus 3. It tells you to factor it. So I want two parentheses, y and y. But one of them must have 8, so I put 8 here. Now, you want two numbers that when you multiply, you get -3, okay? And it, again, on the step 3 of that table, it has given you all the different combination that if you multiply, you get -3. But among all of those, the one that can also give you this middle term, 10y, is when you have, okay, they did it in two different ways, and that's right. You can either do it 8y or you can do it 4y parentheses 2y. Among all the other options that you did, the only one that can give you this middle term, which is 10y, is right there. When you have 4y plus 1. I know this is a little bit tiresome. I mean, you have to crank the numbers to get the right. There's no way to do it, no way around it. You just have to crank the numbers, because that gives you when you multiply, the sum of the outer and inner becomes 10y. You see, the sum of outer and inner must become 10y, and that only happens here. What's the outer? The others are these two. What are the inners? Are in these two. 4y times 3 will be -12y. Plus 1 times 2y, it's 2y. The sum of them is -10y. So that's the only combination that gives me this middle term. Okay, you following me? That's the trick point about it. So the thing on, look at page 352, that green table, that helps you to understand how to do this kind of factoring.
I don't understand that.
You don't understand it?
I'm saying the strategy for factoring on table 2 is
Yeah. Sure. Brian, you don't understand that?
Yeah, kind of lost me.
Okay, let's do it again. Okay, you see on page 352, we have these rules. You know, we had that general term of this factoring. If you have x2 plus bx plus c, okay? So you want to factor, but here is giving you these clue to make it easier. So you need two parentheses, and you need x, in this case, x and x. But in order to find these other terms here, it tells you that the sum of the outer plus the inner must be equal to this bx. So what you need here to put are numbers that when you multiply the outer x times that number and the inner that number times this, and add them together, it ends up to be bx.
Okay. Yeah. I must have missed that when my internet crashed.
Okay, all right, okay, problem.
I missed that part.
Okay, let's look at example here, for example, that the one that we were just talking about. 8y 2 minus 10y minus 3. Okay, I can, you need to have two parentheses, but because here I have the coefficient 8, I can either have 4y and 2y, or I can have 8y and 1y. All right? So either of these things gives me 8y squared. Now, the rule is this: the sum of the outer and the inner must become 10y. Whatever number I am going to put here and here, in both cases, when I multiply the outer, and what are the others? Remember, that's important. This times that, and the inner, this times that, and add them together, you should get 10y, minus 10y. All right?
Okay.
Then it gives you all the choices that you can have to get. Now, okay, let me take that back. On that table, on step 3, it gives you all the choices, and also you're looking for two numbers that you can always get 3, minus 3. The product should be minus 3. That's important. Remember that. So it gives you the options in either case, whether it's 4y times 2y or 8y times 1y, where we can get minus 3. And it gives you all the different combinations. But among all those combinations, the only one that gives you this choice that the sum of the outer and inner ends up to be minus 10y is that point here, 4y plus 1, 2y minus 3. You see, in this case, I have 4 times 8, 8y squared. This gives me, helps me, this gives me a hint. 1 times 3 times minus 3 is minus 3. And if I multiply the outer and the inner and add them together, I get 10y, minus 10y. Do I make sense?
Yes.
Okay, are you okay, Dennis?
Yes.
All right. So let's go back to our PowerPoint. We have what this is called the quadratic equation. Quadratic equation in X, when X is a variable, is the equation that can be written in this form. The things that we were working were all quadratic equation. When A and B and C are real numbers, and A cannot be 0. This is a quadratic equation. Okay. Now, there are two ways to solve quadratic equation. One is to use this formula. You can memorize it and use this formula and solve quadratic equation. The other way is to factor, like on the same textbook. Okay, let's go on to page 356 and 357. We can look at. Let me do that quickly. Okay, one is to use that formula that I showed you. And another one is to factor. For example, we have x squared minus 2x equal to 35. First, I need to make it into a quadratic equation form. I need to bring the 35 to this side. So I add minus 35 to both sides. I get x squared minus 2x minus 35 equal to 0, okay? Then is it, here you have it in a quadratic form. Now you have to factor it, okay? Two parentheses, x and x. I want two numbers. When I multiply, I get 35, and when I add, I get minus 2. I can tell you from now, it's 7 and 5, okay? But when I add them, I need to get minus 2. So when I multiply them, I get minus 35. So one of them should be positive, one of them negative. Which one do you think should be plus?
Should be the
Now, this should be negative. This should be plus. Because minus 7 plus 5 gives you minus 2. And you multiply them together, you get 35. Minus 35. You follow me?
Yeah.
Now, this is not solved yet. You just factor it. To solve it, we want to find value of x that make this thing equal to 0. So you make x minus 7 equal to 0 and x plus 5 equal to 0. That will give you, if you add plus 7 to both sides, x would be equal to 7. If you subtract minus 5 from both sides here, you get x equal to minus 5. These two, these are your solution, 7 and minus 5. Did you guys see what I did here?
Yes.
You see, I made this parenthesis x minus 7 equal to 0, and I made this parenthesis x plus 5 equal to 0. And I solved for x. X minus 7 plus 0, I added plus 7 to both sides. These two cancel, x equal to 7. That's one solution. Another one, do the same thing with this parenthesis, you get x minus 5. Are you following me, Brian?
Well, if you went x minus 7 equals 0, and then you added plus 7 and it canceled out, how's it still equal 7?
No, you see, what I'm saying is for x equal to 7, this parenthesis is 0. Because if I put 7 here, 7 minus 7 is 0. Right?
Right.
And if for x equal to minus 5, if I put minus 5 here, minus 5 plus 5 is 0. So this parenthesis would be 0. You see what I'm saying? You see, we came here to this level, okay? Are you okay so far to up to here? Oh, I get it here.
Yes.
It says these two parentheses are equal to 0. So you can make each one of them equal to 0, because if any of them is equal to 0, it makes the other one equal to 0, all right? So I get x minus 7 equal to 0, x plus 5 equal to 0. Let's first solve this one. If x minus 7 is equal to 0, in order to solve for x, I add plus 7 to both sides. These two cancel, so I get x equal to 7.
Okay.
All right. So that's one answer. To check it, just put it back here. 7 minus 7 is equal to 0. Do the same thing with this parenthesis. X plus 5 is equal to 0 means x is equal to minus 5. If you put minus 5 here, minus 5 plus 5 is 0. So what the answer is telling us, for either x to be 7 or minus 5, this is true. this expression is true. Let's put, for example, 7 here, going back all the way here. Okay? 7 to power of 2 is 49. 7 times minus 2 is minus 14. 49 minus 14 is 35. Now, let's put minus 5 here. If I put minus 5 to power of 2 is 25. Minus 5 times minus 2 becomes plus 10 is equal to 35. So for either x2 equal to 7 or x equal to minus 5, this is true. Are you following me?
Yep.
And notice something. The exponent here is what? 2. And you get 2 answers. This, if this was, for example, if this was 3, you need to have 3 answers. Okay. All right. Are you okay, Brian?
Yes.
Okay, good. Okay, let's move on. Go back. Okay, example 9 of page 357, it's again the same thing. If you notice, they wrote that expression 5x2 minus 33x plus 40, then they wrote down 2 parentheses, and you wanted 2 numbers that they multiply, you get 40. So minus 8 minus 5, you know, that's one option. And if you also want, when you add the outer and inner, you get 33x. And that's the only option, that these are the only 2 numbers that will give you that. So then you make the first parenthesis equal to 0, solve it for x, and then make the second parenthesis equal to 0 and solve it for x. So for 2 answer, x equal 8 over 5 or x equal to 5, that these are the 2 solutions for that quadratic equation. Can you see that? Is that okay for you guys? Okay. So that's one way to solve quadratic equation, by factoring. The other way is using this formula. For if this is your quadratic equation, just plugging into this formula and you get 2 answers. Right. Let's, for example, look at example 358 on page, example 10 on page 358. It gives you the equation, and then you have A is 2, B is 9, C is minus 5. You plug it into that equation, and you solve it, and you get 2 answers for x equal minus 5 or x equal to 1/2. That quadratic equation will be solved. Do you see that? So all you have to do when you use that formula is to find out what is A. A is the coefficient of x squared, what is B, and what is C. C is minus 5. And then plug it into that equation and solve it. Are you okay, Brian?
Yeah.
Okay. Page 359, the same thing. Again, example 11 at the bottom of 358. Give you the quadratic equation. Find out what is A. A is 2, B is minus 4, C is minus 1. Then plug it into that formula. You get the answer, the 2 answers. Sometimes your answer would be you having radical sign, but these are basically your 2 answers. All you can do, the simplest form that you can write is what you have over there. All right? All right. And it's the same thing that when you apply for the set. Now, graph and function, now this is easier, okay? You know, we have the Cartesian coordinate system or rectangular coordinate system. It is named after René Descartes, the French mathematician and philosopher, which, by the way, was a Christian. And also, you have horizontal line, which is called the x-axis, the vertical line, y-axis, and the origin and quadrant. You know, this is a better way to do it. This is called the Cartesian system. Y-axis, x-axis, first quadrant. Everything here, x and y are positive. Second quadrant is here. X is negative. This here is the origin. Here is positive. Here is negative. First quadrant, second, third, and fourth. All right? Let's move on. For example, when you want to plot a point, if I ask you to plot a point, x is 3, y is 5, these are both positive. So you go on the x-axis, 3 points, and the y-axis, 5 points. 1, 2, 3, 4, 5. Then the cross-section would be is this far. If I ask the point 0 minus 5 means x is 0. So x is 0. Y is minus 5. 1, 2, 3, 4, 5. You come here. That's your point. All right. So what is the x value for this point?
Minus 2, minus 1.
Minus 2. What is the y value?
Minus 1.
Minus 1. X value for this one is minus 4. The y value is plus 1. All right? So, point plotting method, relationship between two quantities can sometimes be expressed as an equation in two variables where y is a function of x. When x changes, y changes. We can write it as y is function of x. Means x is a variable, y is a variable which is a function of x. And then we can also graph equation in two variables. And the method of solving is to find a point of intersection. Let's go to example, page 372 and 73, example 3. If that's the example, oh yeah, that's a very good one. Now here, for example, you see some practical point of what we are talking about. Maybe I don't think I can. We can just look at. You see, it says the toll of a bridge costs $2.50. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $21. With a discount pass, the toll is reduced to $1. The monthly cost Y of using the bridge X times can be described by the following formula. So, you know, the monthly cost is Y, depending on how many times you use it. Without the pass is $25 or 2.5. Do you understand that formula? Okay.
Yep.
All right. Now, this helps you to know where should you buy, when should you buy? Should I buy that pass or not? Now, it says if you get a discount, you have to pay $21, but then the pass will become $1, the number of times that you go. So you got 21 plus 1 times x, or y is equal to 21 plus x. Okay, now, we plot that. In other words, look at page 373, figure 7.5. When you plot, it means give different value to x, find the value for y. If x is 0, y is 0. If x is 2, 2 times 2.5 is y is 5. And so on and so forth. all the way to 16, okay? Are you guys following me? Yeah, the table. The first one is without the discount pass. Okay, the second table is with the discount pass. So you give value to X, you find the value for Y, but remember, for each of them, you got to add a $21 because that's the total price of the pass for the month. When you look at these things and then you graph them, you know, you got all the, you have 1, 2, 3, 4, 5, 7 points for each case. You graph them on that line. You see figure 7.5. The blue line is without a discount. The red line is with the discount. The point that they intersect is when there is the point 14 and 35. What does that mean? Can you tell me what does that mean? You know, if you look at the tables, it's when they are when X is 14, meaning what? Meaning that you have passed that bridge 14 times a month. The price of whether you don't buy a discount pass or buy the discount pass is the same, $35. It is only after that that the price is less. You know, when you cross the bridge 16 times a month, the price is what? No. That's without, yes, that's without the pass. But how much is it with the pass? $37. So how can this help you with whether I should buy the pass or not? How can this help you? It is telling you it will only help you to buy the pass if you cross that bridge more than 14 times a month. If you're not crossing the bridge more than 14 times a month, it is cheaper not to buy the pass. Because notice, let's say if you cross 10 times, without the discount, the price is $25. With the discount pass, the price that you pay is $31. You see that? Do you see that, Brian?
Yep.
Okay. So that's one very practical use of this formula. 376, example 6. Okay. Again, on page 376, it says, look at example number 6. Again, they give us two functions. The first function, fx is equal to 2x. The second function, g of x, is 2x plus 4. I can tell you just by looking at those functions, and you should be able to do that too. When you see this function, the exponent, the highest exponent is 1. It means that when you're going to graph it, it's going to be a straight line. If it was x squared or x cubic, you will have curvature. But when it's 1, you get a straight line. So to graph, you have the function, just put different value for x. Fx is 2, you just put -2, -1, 0, +1. You get the value for y. And you get 2 points. And you draw the line. It's that blue line. Now, look at the other line. Gx is 2x plus 4. You give them the same points, and you find the value for g of x or y. And if you notice, it is parallel to the first one. It just 4 points move toward the right, 4 units. Because if you look at the formula, one is 2x, Other one is 2x plus 4. Are you following me, everybody?
Yes.
Yeah, that's how you draw or graph these two lines. Brian, is that clear for you?
Yeah.
So you have a function, you give different value for x, find the value for y. You got 2 points, x and y. Then you find a dot and find more dots and then a straight line, and you draw the line. If we go to page 380, basically the same. Has given you different function, different example, like number 21, y is equal x to minus 2. Give different value to x, find the value for y, and then graph it. All you need to do to find x and y and find a couple of lines, two or three dots, and then connect them. Is this clear for you guys? If it's not, please tell me.
Mm-hmm.
It's progressive.
Okay.
Yeah.
Yeah. All right. Yeah. It's just like a machine. You just put a value and you get something out. Put different value for x, get a value for y, and all you need to do is find 2 points and then connect them. Got your line. In fact, here is basically what I just said, how to graph linear function. All equation a, x, b, y equal to c are straight lines, and provided a and b are not both 0, and such equation are called linear equation in 2 variable. Now, we talk about x-intercept and y-intercept. X-intercept means where that line intersects with x-axis. In order to find that, make x equal to 0. It gives you the x-intercept. Or in order to find y-intersect, makes to look at x-intercept, set y equal to 0, solve it for x. If you want to find y-intercept, make x equal to 0 and solve it for y. When we talk about x-intercept, meaning the point that the line crosses the x-axis, or y-intercept is the point that the line crosses the y-axis. Okay, is this clear? Let's move on. Then another important thing that we have in graphing is slope. A slope is basically rise over line, change in y over change in x. You look at here in this diagram that I have for you, the basic formula is this. You've got to memorize this. Y is equal mx plus b. M is the slope, the change in y. Rise over run. Rise is, when we go from the difference between y2 over y1 over x2 minus x1. That gives you the slope. Whether it's going, if the slope is positive, it's going up. If it's negative, it's going down. All right. The space, positive slope going up, negative slope is going down. Graphing y-mx b using the slope and y-intercept, plot the point containing the y-intercept on the y-axis, the point where x is 0. Obtain a second point using the slope, then use a straight edge to draw a line through the 2 points. Let's look at these examples. I think this is easier to understand. Let's look at page 388. Example number 4. It gives us 2x plus y equal to 0. Let me fact. Example 4. Example 6. Okay, let me just do one of them because of time. And then okay, look at example 4 on page 388. Remember our formula. Y is equal mx plus b. And m is the slope. They give us this equation, this linear function, 2x plus 5y equal to 0, all right? I need to change it to this form. So I add minus 2x to both sides. These two cancel, so I get 5y is equal to minus 2x, basically. I divide both sides by 5. I get y is equal minus 25x plus 0. This 0, it tells me this is the y-intercept. That's where the line crosses, the value of y becomes 0. It crosses the y-axis. This is my slope when you compare this equation with that. Tell me, where does the line goes up or down? Down, because it's negative. So if I have this Cartesian product, sorry. If I have this Cartesian product, it gives slope is rise over run, remember? So the difference between the rise over run is minus 2 over 5. So my y-intercept is 0. I know it from here. And this is the vertical line is a y-axis. So this is my y. This is one of my points. Actually, no, I'm sorry. Yeah, it is. And then I need to have to go down minus 2, 1 and 2, and plus 5. 1, 2, 3, 4, 5. That's my second one. And this is my line, and it's going this way. You see that? You see what I did?
Yep.
Okay. All right. The other ones are exactly the same way. You see, like if you look at example 5, it tells you y is equal minus 4. So basically, this is telling me my m is minus 4 over 1. No, actually, no, there, that's it. My b is, this is my y-intercept. So if I want to draw it here, the line should be 1, 2, 3, 4 here. That's my line. Okay? Minus 4. All right. Or like, look at one more. Are you guys following me?
Yes.
Yep.
Let's just do one more. Example 6. It says graph x equal to 2. Simple. Draw the Cartesian line. pick a point, x is 2, 1, 2. All the line, this will be a line that goes right here, because all of them will, their x will be equal to 2. Now y can be different number, but x is always, on this line, x is always 2. All right? Let's move on. Okay. Now, we can solve linear system by graphing. For system with one solution, the coordinate of the point of intersection of the line is the solution. If you graph, they give you two equations. If you have two linear equation or three linear equation, doesn't matter. When you graph them where they intersect, that's the solution. Let's look at example 395 and 396. Okay. Let me go to my graph. Okay, look at example number 2 on page 395. So you're on page 395, example 2. We have, it tells us x plus 2y is equal to 2, and x minus 2y is equal to 6. It tells us to solve this by graphing it. To solve it means find a value for x and y which makes both of this true. So I come and draw the line. Okay, sorry. First, this one, x plus 2y is equal to 2. For that one, x plus 2y equal to 2. If I give 0 to x, y would be 2y is equal to 2, y is equal to 1. So one of my point, it would be x is 0, y is 1. That's my point. And if I give 0 to y, x is equal to 2. So for y equal to 0, x is 2. So this is my first line, which they go through like that. Okay, I'm sorry, I cannot draw straight with my hand. Then we do the second line, x minus 2y equal to 6. If I give 0 to x, y would become minus 2y equal to 6, or divided by 2, y become minus 3. So for x equal to 0, y is minus 3. 1, 2, 3. That's my first point. If I give 0 to y, x is equal to 6 because this cancels. So 1, 2, 3, 4, 5, 6. That's my second point. So that's the line. Sorry. This point is a solution where they cross, which is on the graph shows is 4 minus 1. So for x equal to 4 and y equal to minus 1, this system is true. That's the answer. You can put, if I put 4 here, I get 4. Minus 1 for y, I get minus 2. 4 minus 2 is 2. And 4 minus 1 time plus minus 2 become plus 2 is 6. So you see, for x equal to 4 and y equal to 1, both of these are true. And we find that by graphing. You see that? You see that, Brian?
Yeah.
Okay. Let's move on. I guess this is basically what I just said. Solving linear system by addition, if you have ax plus byc, if you want to solve, if this multiply either equation on both equation by appropriate non-zero, so you get the sum of the x coefficient and the sum of the y coefficient. So the sum of the x coefficient or the sum of y coefficient is 0. Add the equation in the step 2 so that the sum is in one variable. Solve the equation, then back substitute. The best thing to do is look at an example. Let's go to page 399. Okay. Look at example 5. We have 3x plus 2y equal to 48 and 9x minus 8y equal to minus 24. In order to solve this, it says multiply by minus 3 okay, it's trying to make them the same. If I multiply both sides here by 3, I get 9x plus 6y equal to minus, yeah, that was minus the equation. Oh yeah, I'm multiplying by minus, sorry. Minus 144. Okay, I multiply this one both sides by minus 3. Okay, then I add these together, these two cancels. So I get minus 6y and minus 8y, I get minus 14y. Minus 24 and minus 144, I get minus 168. Divide both sides by this coefficient, minus 14, and these two cancel, and this is equal to 12. Now, I got y is equal to 12. Now, you can back substitute this in either of this equation. You find x, with x would be equal to 8. You know, just plug in instead of y 12 in either of this equation, solve it for x, and you get the value of x. All right? Let's move on. Are you okay, Brian?
Yes.
Okay, good. Now, graphing linear inequalities in two variables. Let's see how much time is left. This was a lot. Yeah, we have time. Replacing inequality symbol with equal sign, graph the linear equations, then choose a test point to see which part of the plane does this inequality holds. Then shade that part that is true for that inequality. Let's do an example. Example either 1 and 2 on page 409. Let's look at example number 1. Okay, so we are on page 409, example number 9 and 1. I'm sorry, page 409, example 1. It says graph a linear inequality in two variables. We have 3x minus 5y greater than or equal to 50. So first, assume this is an equal sign, 3x minus 5y equal to 50. Just find y-intercept and x-intercept. For y-intercept, make y equal to 0. If you put 0 for y, x would become 3x equal to 15, or x is equal to 5. If you put x equal to 0, you get minus 5y equal to 15, and y would be minus 3. Okay? Then, again, this Cartesian product, Cartesian system. So, one of our points is y is 0, x is 5. 1, 2, 3, 4, 5. Another one, x is 0, when y is minus 3. 1, 2, 3. So this is my line. But this is an inequality. So in order to graph that, you got to find a test point. Let's just pick easiest one, 0, the origin. If I put 0, the point 0, 0, x is 0, y is 0, would that make this inequality true? 3x, I mean, if I put 0 for x, would be 0 minus 0 is greater than or equal to 15. No, that will not be true. So it cannot be over there. It cannot be any point over here. So my area is here. So when it comes to graphing the inequality, it would be this shaded area here. Pick any point in this shaded area. Let's, for example, y minus 4, x 6, plug it here. 3 times 6, 18, y minus 4, or minus 5 times minus 4 will be plus 20 is greater than 50. So did you see how I did that? I changed this into an equality sign. I put the y-intercept and the x-intercept. I draw the line. Then you have to find the test point to make sure which side are we talking about. I put 0. If I put 0, you say, no, it doesn't work. So it cannot be that side of the line. It has to be the one under. So, all right. Okay, Brian?
Yeah, I'll get there.
Okay. All right. Let me see how many more do we have? No. Let's see. Let me check something. Okay. Exponential function with base b is defined as this. You know, these are the things that you just have to know. Y is equal, the function y is equal base b to power of x, or function x b to power of x. B is a positive constant other than 1, and b is greater than 0, and x is any real number. Like if you look at page 423, look at example 1. It gives you page 423, example 1. F of x equal to 2 to power of x. The b is 2 to power of x. Base 2 to power of x. So you give different value to x, and you find a corresponding value for y. And if when you put those dots on the graph and connect them, you get that curvature. And you get a curvature because it's exponential. It's not a linear. Okay? Let's move on. Now, the other way of doing it is logarithmic. Logarithmic function is just reverse of exponential function. logarithmic function would be written like this. F of x is log base b of x, where x is greater than 0 and b is greater than 0 and b is not 1. So when we have something like this, we say y is a log b of x. It's the same as to write it as b to power of y is equal to x. These two are equal. They are different way of saying the same thing. One is logarithmic form, the other one is an exponential form. You just have to memorize this thing.
You're speaking a whole different language right now.
These are different functions. Okay. And what is that? For example, if you go to page 427, example number 4, look at the example number 4 of page 427. It says graph y log 2 of x. Now, log 2 of x means log base 2 of x. It's the same as writing as 2 to power of y is equal to x. 2 is the base, y becomes the variable. So if I give different values for y, I get different x. You got those points on the table, and then you connect the dots on the graph. You just have to remember, in a logarithmic function, you see that green area at the top of page 427. This is logarithmic form. Y is equal to log base b of x. That's the same as b to power of x is equal, b to power of y is equal to x. One is called logarithmic function, one is called the exponential form. All right? Okay, let's. Now, quadratic function that we are talking about, when we want to graph it, it becomes what is called parabola. Push this. And to draw a parabola, first, we got to find out whether it's upward or downward. That depends on whether the coefficient is greater than 0, is it positive, or is it negative. If it's positive, the parabola goes up. If it's negative, it goes down. Then you got to find the vertex. This is the function for finding the vertex. You got b over 2a minus. When you find that, the vertex is the x-coordinate. On the x-coordinate, and then you find, you put that in the function, you solve it for y, then you plot the intercept. You got the vortex and you know whether it's up or down, and you find the 2 points, you can connect it. Let's go to page 430. I know this is too much for you guys, but just go one at a time. Look at example number 6. Okay, maybe I go here. Okay, so we are on page 430 and example number 6. Graphing a parabola. Our function is this. Y is equal x squared minus 2x minus 3. First, find is this parabola goes up or down. What is a in this formula? Tell me what's a. A is 1. A is the coefficient of x squared. Remember?
Nope.
Remember, this was the formula. This was a general formula for the quadratic formula. 2x squared plus bx plus c. So this coefficient of x squared is a. This is a, this is b, and this is c. So a is plus 1. So I know from now, even without graphing it, that this paraboloid goes like this, going upward. Then find the vertex. The vertex is minus b over 2a. What is b? Tell me. Minus 2. See that here? B is minus 2.
Okay.
2a. A is 1. So I put here, I get plus 2. I'm sorry, this should be times. Over 2 is equal to 1. So this is a vertex. So I find the x coordinate of the vertex is 1. Now, in order to find the y coordinate, you put that 1 into the formula. So you get 1 to the power of 2 is 1, minus 2 times 1 is 2, minus 3, so you get minus 4. So I find the vertex x and y. So in other words, let me see if I have this Cartesian product, I know it's going that way, and I know this is the vertex, plus 1 and minus 4. I'm sorry. So minus 4, 1, 2, 3, 4, plus 1. I know it's here, and I know it goes this way. All right? Now, I need to find the x-intercept and y-intercept. In order to find the x-intercept, make x equal to 0. So if you put x, replace, or actually, if I put x equal to 0, I get the y-intercept. If that's the equation, I put x equal to 0, y would be minus 3. And if I put y equal to 0, x would be, wait a minute. Okay, so right. If I put y equal to 0, I get minus 3. So one of my other points is this. I got x 0 and minus 3. So let's plot that before doing anything else. X is 0, y is minus 3, 1, 2, and 3. So that's one of my points. And then I need to make y equal to 0. So I have x2 minus 2x minus 3 equal to 0. Remember the factoring? X and x, two number, multiply become 3, add become 2. I need 3 and 1. I need them 1 plus, 1 negative. I need minus 3 and plus 1. So when they add up, become minus 2x. So my other point is I get x equal to 3 and x equal to minus 1 for y equal to 0. So I got all my points. I got all the dots that I need. X3, y0, and x minus 1. So these are my lines. Are you guys following me?
The C, where did the C go in that plugging in the a squared before it is?
Here?
Yeah.
That told me when I come here and make y equal to 0, I want to find the y-intercept. When I make y equal to 0, that tells me that these two numbers that I'm looking for factoring, their product, when I multiply them, must become equal to -3. I need two numbers that when I multiply them become -3. When I add them, become -2. And the only number would be -3 and +1. Okay? And then when you make it equal to 0 and solve for x, these are the numbers that you get and formula. Brian, are you okay?
Yes.
Okay, good. And that's how you draw that. Okay, let's go. Oh, we are done. I know you guys are disappointed, but we are done.
No, it's brain free.
Yeah. Just go over them in your textbook. If any questions, send me email. I'd be more than glad to help. But enjoy tomorrow.
New concepts.
Tomorrow is a good Thanksgiving day. All right. Let's close with a prayer. Brian, would you close us with a prayer?
Sure. Father, we thank you for this day. We thank you for your grace and for your mercy. We thank you, oh God, for just the knowledge that we've gained. We thank you for our professor who's poured into us. And I pray for my fellow students that you would help us to grow. Lord, you've shown us, Heavenly Father, that even through numbers, oh God, that you reign supreme. And so we're praying, thanking you for this day. I pray for the fellowship of family and friends tomorrow as we celebrate Thanksgiving. We thank you for the rain. I pray for safe travels for those who are there on campus to get home safely. And then bless us, Heavenly Father, as we sleep through the night. Let us arise tomorrow morning to give you praise, glory, and honor. In Jesus' name we pray. Amen.
Amen. Amen. Have a blessed Thanksgiving day.
Thank you.
Take care. God bless. Bye-bye.
Same to you.